Okay, so this video is an introduction into the key variables, I guess, that are behind motion in physics, and really just trying to paint a picture of the direction that we're going to go with these key ideas. So I guess in terms of some letters that you're going to be seeing quite regularly throughout what we're learning with physics, you're going to be seeing T, we're going to be looking at U, V, A, and also S. And each of these letters is representing a really important variable for us in these motion questions that we're going to be discovering how to do. So firstly, the variable T is representing time, as you could probably imagine, and time is going to be measured in seconds for us. So the SI unit or standard unit for time is seconds, and that's what we're going to be looking to use throughout the questions that we're doing. I'm going to jump across here to A, and A, as you might imagine, is representing acceleration. And we'll come back to what that sort of represents for us shortly. And acceleration is measured in meters per second, or you might also see that represented as meters or ms to the -2, which is representing the same thing. And we'll come back to that shortly, as I said. If I sort of jump down here, I've got u and v. Now, both of these are sort of velocities. However, u is representing an initial velocity, where v is representing a final velocity. Now, you might find in some textbooks or online, you'll see some areas where u is represented by v0, and v0 and u are very much interchangeable. They're representing the same thing, with it being an initial velocity, but I'm going to be using u for the sake of what we're doing. If you're trying to remember which one sort of is which, I always try and think about u coming before v in the alphabet, and that's because initial is before final. S is going to be representing our displacement or distance, okay, and both of those are measured in meters. And over here, our velocities, I should have mentioned, are represented by ms to the -1, which is the same thing as meters per second. So I guess in terms of these, the main ones I just want to focus on for now are the velocities and the accelerations. If we're sort of thinking about some basic physics concepts, what we're sort of saying here is that an average velocity, as a lot of us would be aware of, an average velocity is equal to a displacement divided by time, or distance divided by time. And I'll get stuck into what the difference between distance and displacement is in the next video. So for example, if I'm sort of able to travel 50 meters and I do it in a time of 5 seconds, what we're saying is that that would be an average velocity of 10 meters per second, or 10 ms to the -1. In terms of acceleration, acceleration is really described as the rate at which our velocity is changing with respect to time. So whether that's an acceleration, which means we're moving or getting faster, moving forwards or in a positive direction, or a deceleration, which is really implying that we're slowing down. And that is represented by v take u over t, or we have this other notation, which is change in v. Now, this triangle sign here represents delta slash change in. Okay, in other words, saying how much it's changed. And what this is implying is that if we've got a change in velocity, so if I started off with a velocity of, say, 0, so let's say I was initially at rest, and then I accelerate to a rate of 8 meters per second, and I do that in, say, a time frame of 2 seconds, then what we would say is we'd be jumping into this equation saying A is equal to V take U over T, and therefore we've got 8 take 0 over 2, which is equal to 4 ms to the -2, and that would be our acceleration. So these are some really important letters that you're going to see throughout this topic. We've got T for time, as we said, A for acceleration, U and V for 2 different velocities, initial and final, and S for the displacement and the distance. And in the next video, I'm going to unpack sort of what the difference is between speed, which is a word I haven't really used over here. Average velocity and average speed might be represented very similarly, and also the difference here between distance and displacement.